Okay, today we're going to talk about a little introduction to trigonometry. Now, the definition of trigonometry is triangular measurement. Now, so we're obviously going to deal a lot with triangles. Now, what I would like to do first, though, is kind of get through some basics of how you label triangles. If we use this as our example, we'll just call that the right angle. The way we first of all label vertices is we use capital letters. So if I use capital A, B, C, it doesn't really matter what letter we're talking about, but we do use capital letters to identify vertices. And then what we do for the sides is we use lowercase letters, and we use specific ones. In this case, I would call this A, and I would call this B, and I would call this C. And you notice that the lowercase letter corresponds to the angle opposite. And that's on purpose, so that way when you're talking about a situation, you don't always have to have the picture in front of you. You can identify sides by is it a capital letter? Well, that's an angle. Well, if it's a lowercase letter, then it obviously is opposite the angle with the corresponding letter. So let's get into some of these things. One is what I'd like to start out with is just simply identify the 6 different trig functions. Now, you might know 3 of them. If we call, now here's something that we tend to do, is since we're talking about trig, and trig is a Greek, has some Greek origins, we tend to use Greek letters. What if I call this angle right there theta? The first trig function we're going to talk about is sine of theta. The next one we're going to talk about is cosine of theta. And the third one we're going to talk about is tangent of theta. Now, you might know a little phrase that you probably learned in your algebra or geometry class, and that phrase being SOHCAHTOA. Now, I like to write it kind of a special way. I like to write it like this. But that stands for sine equals opposite over hypotenuse. Opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And tangent is equal to opposite over adjacent. So if we're talking about this angle right here, the tangent of this angle would be A over B. Opposite side over the adjacent side. Cosine would be B over C. Now there's 3 other trig functions, and they are the reciprocal functions of these 3. The first one that we can talk about is something that's called cosecant. And cosecant of theta equals 1 over sine, which if sine equals opposite over hypotenuse, that means this is hypotenuse over opposite. The next one is secant of theta, which is 1 over cosine. Now you notice this last time I abbreviated sine. That's an abbreviation for sine, S-I-N, and cosine, C-O-S. And if cosine is adjacent over hypotenuse, that means this one is hypotenuse over adjacent. And lastly is cotangent. And that's 1 over tangent. Tan is the abbreviation. That would be adjacent over opposite. Now those are the 6 trig functions that we're going to talk a lot about. Those are things that you definitely should have memorized. So let's do a couple examples here and jump right in. So let's say I have a triangle. Let's say I have a right triangle. And this sides are 5, 12, and 13. And we'll call this angle theta. So if I want to know what are the 6 trig functions of that angle, I could say, all right, well, cosine of theta is adjacent over opposite, 12 over 13. I could say sine of theta equals opposite over hypotenuse. Tangent of theta, opposite over adjacent. And then the reciprocal ones are easy. Once you know these, they should be easy. So let's just go with secant. Secant, remember, now abbreviation is SEC. is 1 over cosine, so that means it's 13 over 12. Cosecant, CSC, okay, is the abbreviation. It's 1 over sine, so 13 over 5. And cotangent, COT, is 12 over 5. Pretty basic, pretty easy right there. So, give you an opportunity if you wanted to hit pause. This would be a good time. You can. I'm going to give you a triangle, 7, 24, 25, and we'll call that theta. And so, see if you can identify the 6 trig functions. Okay, so here are the 6 trig functions. I'm going to start with cosine. Cosine of theta is adjacent over hypotenuse. Sine of theta is oops, sorry, I said adjacent and I wrote opposite. This should be 24. Opposite over hypotenuse. Tangent of theta, opposite over adjacent. And then all the reciprocals, secant of theta is just 25 over 24. Cosecant, 25 over 7. And cotangent equals 24 over 7. Kind of a small thing, but yet really important, is that notice that every single time I'm using this little angle measure here, and that's important because that's telling you, remember, cosine, just all it is a word that means adjacent over hypotenuse. Well, you need to know what is adjacent to, or what it's opposite to. And so that's why you always have to have these angle measures in there. That's important. Okay, let's move on to a different type of example. Similar but different. Let's say we're given that sine of theta is equal to 4/5. How would you find the other 5 trig functions? Well, the way I would do it, and this is the way I tend to do everything, is I try to create a picture. So I know we're dealing with some sort of right triangle. It doesn't really make a difference what the right triangle looks like other than it being a right triangle. And I'm going to pick one of the angles to be theta. Okay, so if sine of theta equals 4/5, that means sine is opposite over hypotenuse. So, well, if I know that, then I could figure out what this side is. Now, you might know your Pythagorean triples from geometry, but if you don't, you can just use Pythagorean theorem. You can do x squared plus 4 squared equals 5 squared. And you'd come up to be x is 3. And then from there, you could do all your other 5 trig functions. Now I could say, all right, well, cosine of theta is 3/5. I can now say tangent of theta is equal to 4/3. I could now say secant of theta equals 5/3. I could say cosecant of theta equals 5/4. And cotangent of theta equals 3/4. So the big thing there is just simply, if you have this scenario here, this ratio, put it on a triangle, take a look, see what it says, and then use that triangle to come up with the others. Okay, hopefully this is making sense so far. Let's move on. Now let's actually put a little application into some of this. So let's say I have a triangle, and let's put a couple things in here. We'll call that x, we'll call that 18, and this 31 degrees. So, how would I figure out what x is? And this is one of the main purposes of trig, is it helps you find this stuff. Well, all you're going to do is you're going to simply create a trig function. So, based upon this angle, what trig function could we create? Well, we have an adjacent side, and we're looking for the hypotenuse. So, the trig function with adjacent and hypotenuse would be cosine. So, I take cosine of 31 degrees equals adjacent over hypotenuse. And what we're going to do is we're going to put it in a calculator ready form first. So I need to get that x by itself. So I'm going to multiply by x on both sides. And then I'm going to divide by cosine of 31, and I'd end up with this. And then I'd take my calculator, and I would divide 18 divided by cosine of 31. and 20.999. So why don't we just say it's about 21? That's it. Pretty easy. But what if I'm given a different set of situation or circumstances? Let's call this x is 12. And what if I'm looking for my angle? Well, you still start with what am I given? Well, based upon this angle, I'm given opposite and adjacent. So I'm going to create a trig function using tangent. This time I'd say tangent of x equals opposite over adjacent. Well, this is where we're going to use an inverse tangent. Okay, so what we're really doing, and you don't have to write this down, or at least I don't ask my students to write this down, is we're going to take the inverse tangent of both sides. And what happens over here is these cancel, and we end up getting this. And on your calculator, if you notice, okay, above your trig functions right here, you'll see that you have your inverse tangent. Those don't mean reciprocal, those mean inverse. So tangent of -1 doesn't mean cotangent. Okay, so we are going to use that second inverse tangent, and I would then type in my 5/12, and there you go. And that tells me that that angle measure is 22.6 degrees. So use that inverse tan every time you're looking for the actual angle measure. You just use the regular tan, cosine, sine if you're looking for a side. Okay, let's keep moving on. There's a lot of things going on here. Okay, what about this one? What if I tell you that cotangent is equal to 3/4? How do I figure out what that angle measure is? Well, the difficulty there is that we don't have a cotangent button. Okay, we only have sine, cosine, tangent. So what you need to do is you need to change that to a sine, cosine, or tangent. Well, we know that cotangent is 1 over tangent. So I can just switch it like that. And since I have a fraction equals a fraction, I can just reciprocate both sides. And then back to the calculator. I'm looking for the angle, so I'm going to do inverse tan again. And there we go, 53.1 degrees. Okay. Okay, we're going to skip over this one right there. Okay, we're going to do one more example here. I know there's 2 written here. We're only going to do one. It says, solve the right triangle given that A is 14 degrees and B is 6. Now, this goes back to what I was talking about originally. Notice it's a capital letter, so that's telling me it's an angle. And this is obviously a lowercase letter, so it's a side. So I am going to go through and try and figure out, well, what could be the rest of the triangle. Well, the one part that I am kind of missing here, and it's somewhat important, is I'm going to tell you that C is a right angle. So I know that that's going to have to be C. So if I call that A and I call that B, so 14 degrees, got that. This is √6. So I need to figure out what C is, what B is. Now, before I do any of that, though, what I can figure out right away is what this angle is. Well, obviously, the triangle sum theorem says that all angles in a triangle have to add up to 180. So this one is 76 degrees. And then to figure out the others, let's say we figure out what B is. Again, based on this angle, I can do opposite over adjacent. So I can do tangent of 14 degrees equals B over √6. To get into calculator-ready form, I'm going to multiply by √6. So I get √6 tan 14 degrees equals B. Break out the calculator, type in √6 tan 14, and I get 0.61. Okay? And then to figure out what C is, I can do another trig function, or I could possibly figure out with Pythagorean theorem. So, hopefully that makes sense. If you have any questions, feel free to ask. Thank you.